Okay, today's lab is one on the conductivity of solutions. And you might be able to do this one at home if you can rig something like this up. It's kind of a neat little setup to test your conductivity of different ones. So essentially, ionic compounds that dissolve in water do so by ions being pulled from the crystal lattice to form a solution. When free ions, charged particles, are present, the solution is a good conductor of electricity, right? That's what we learned already. Many covalent compounds that dissolve in water form solutions of non-charged particles. These do not conduct electricity, right? And it all has to do with the ionization of the different materials. And so for this particular one, what it involves is a light bulb with a light bulb holder with two probes in there, okay? And what you do is there is also a way of electricity goes to this and it goes through, and then whether if it's open here, the light bulb does not light up. If there are ions in solution, the light bulb will light up, and the degree to which it lights up tells you how much what the strength of that ionic solution is. So, thinking about that, what you have is they've got a patch cord with alligator clips, distilled water, dry water, all these different materials here, and you'll see at the very end you have a table for recording them. Now, so if you set that up if you have solids there, with the lamp unplugged, you lower the electrode in there and just touching the solids. Okay. Now, the one that they have you touching the solids on is sodium chloride. Okay. Sodium chloride, just table salt, right? And so if you have table salt there, it is not a solution. So you are not going to get any light on that light bulb. Now, if you were to put it into a solid such as a potato or a vegetable that's got and a lot of vegetables have a pretty high water content, potatoes actually can conduct electricity. And there are things online or posts online that show you how to make a potato-powered radio. Okay, that's an interesting one to do, or you can, but even just lighting up a light from a potato, it's not really bright, but it does light up. But then what you're supposed to do is you're supposed to then take each of the solutions, and these are listed in the table at the end of this one for the various ones, and that's this table right here at the end. So what you're going to do is you're going to think of this in terms of distilled water, okay, tap water, sodium chloride, in other words, this salt in water, hydrochloric acid, acetic acid, which is what vinegar is, ethyl alcohol, and sodium hydroxide, okay, and then glycerin and sugar solution. If you don't have a sodium hydroxide solution handy, this would usually be something like Dow made a lot of these. They call them Dow bathroom cleaner. Those are essentially sodium hydroxide of various solutions, or oven cleaner, easy off oven cleaner. Both of those are basically sodium hydroxide solutions. Many of them foam up quite a bit, but when they condense back down, they essentially are a solution of sodium hydroxide. A different one that could be used in that place would be ammonium hydroxide, which is your window cleaning solution. Glycerin, and then a sugar solution, okay? So those are the different ones, and you should be able to, just from your knowledge, and then what you would observe and what you can make about these different ones, okay? So for example, on this right here, dry sodium chloride, okay? Dry sodium chloride did not conduct electricity. But if salt is put into the solution, you've got electrolytes that are present, don't you? So there you can say, you can make state your two observations, and then what you actually can conclude from that. That there is not an ion flow in the dry sodium chloride and the crystalline form. There is an ion flow possible when you have that same sodium chloride dissolved into water. Okay? Then distilled water and tap water. Distilled water is water where there are no ions left behind in it, right? The water is distilled away, and so you've purified it. No ionic concentration whatsoever. Tap water, well, it depends upon what your tap water is. Almost all wells I know around here have got certain ions in them, and those ions will conduct electricity. Okay, and so those would be some of your observations for those. And then hydrochloric acid and vinegar. Okay, comparing those. Hydrochloric acid, we saw from our other exercises, is going to completely dissociate, isn't it? Whereas we saw from the vinegar, that only partially dissociates. It's and we did the titration curve for that last week, where we saw that it starts off at a higher pH, right? Which means a lower level of ionization, and it slowly climbs. It climbed, but even that slow climb, though, as more NaOH was added, was much more rapid than the titration with the sodium hydrochloric acid with the sodium titrant sodium hydroxide. I was having a tough time saying sodium hydroxide there. But anyway, so this one is dissociated much more than this. Okay? So the greater the degree of dissociation or ionization, the greater the amount of electricity that is going to flow, the brighter the light. So what should your results be there? Okay? And then you can continue on. And then what were good conductors, what were non-conductors, and essentially you should be able to make some sort of conclusions there based upon all of this, right? And then, for example, the other one's ethyl alcohol. Is there an ion in there? No, there's not. Sodium hydroxide? Well, yes. Yeah, sodium hydroxide. We saw how well they dissociate last week, didn't we? Glycerin? That's just that's sort of like pig fat, right? Very low molecular weight pig fat. That's not going to conduct anything. And then sugar solution. Okay. Does that have ions in it or not? So anyway, those are the different ones. Record your observations if you're able to do it. If you're not, just figure out what would probably happen there based upon your knowledge of the ionization potential for those different materials. And that's it for this lab. Fill out their lab report and submit that along with your homework at the beginning of class next week. And that's the end of this recording.